Hello everyone, hope you all are doing well. So today we will start our new topic, that is atom. In atom we are having nucleus and orbits stabilization. So first of all we will talk about the orbits stabilization as we have done previously. Like if we are having L shell, okay. In L shell we are having 2 electron, so it's unstable. We are having 4 electron unstable, 6 electron unstable, 7 electron unstable. But when this shell got an 8 electron, so it got stable. So how it got stabilization? It got stabilization by the chemical reaction. Okay, so that's the stabilization process of the orbit. But if we will talking about the nucleus, mean the decaying process of that, like if we will talking the decaying process of the nucleus, like here are the 4 methods. Number 1 is proton and neutron will be greater than 1, neutron is greater than proton, or proton is greater than neutron, or proton is equal to neutron. So talking about proton, neutron is greater than 1, in that method what happens, that both will emit out its energy or decaying to form an alpha rays. When, like we are having here, proton and neutron is greater than 1. Now here we are having proton and neutron both are greater than 1, but if what it could do, it's emit out or it will decay, it will do it will change its form when it emits out, so it will change its form in alpha ray. That ray came out is called alpha ray. Okay, now talking about second, we are having neutron is greater than proton. It's not stable, means proton neutron is greater than 1. Like we are having helium we are having 4 and 2. 2 are the proton, okay, and 2 are the neutron, but it's greater than 1, so it will take a time to be an stable. So when it will got stable, so it emit out its energy, it will decay, it's both proton and neutron, so it will got stable, and that proton and neutron what decaying, what energy it's emit out, that energy is called alpha ray. Now move to the neutron is to proton, means where the neutron is greater than proton, means we are having high neutron than proton, so the neutron emit out, like we are having plus sign over here and minus sign over here. Okay, more put one more. Now we are having more neutron and less proton. Neutron is greater than proton, so what we will do, there this neutron, one neutron will emit out to be stable. Okay, and that emission will be decaying, it will call minus beta ray. Likewise then we will be remaining one proton just, plus now we also taken out minus one electron, so this is called the negative electron. So when it's emit out, it decaying, so it produce a beta ray. Okay, after that move to next, number third point, we are having that proton is greater than neutron, so we are having more proton than neutron. So what we will do over here, that here we are having 2 proton 1 neutron. Again we will, previously we are having negative, we are emitting out a negative energy, but now we are emitting out positive energy to get stable. So when we will take out the positive, so here will be 1 proton remaining, plus, okay, 1 electron, means a positive electron is also called positron. So when it's emit out or decaying, that process, in that process the thing that is emit out is called positron. Move to the next last one, we are having that proton is equal to neutron. When proton and neutron both are on a same position, means both are equal. Okay, now it's stable, but it's hot, means like if we are taking an example of tea, if we are drinking, if we are taking a tea, so it's hot, so we are putting it to be cold to drink. But same happens over here, means the thing is stable, but it hot, means it's but x-ray, it's gamma ray, so it take time to be stable, means this thing is hot, like we are 8 and 8. Recently it do the reaction and it hot too much, so it got stable to be cooled down, and in that cool down process the ray came out, or this produced a one ray that is called a gamma ray. So these are the process to the stabilization of the nucleus. So these are the four process. One, proton neutron is greater than 1. Second, neutron is greater than proton. Third, proton is greater than neutron. And fourth, proton is equal to neutron. Hope you understand today's lecture. Thank you so much for listening.